you send out a sharp pinging sound, and that sound goes out through the water, and it reflects and comes back just as the radar wave would go off and reflect back. So that was the basis of an awful lot of what was done to try to track something, but that is only marginally useful. You really have to be close to a target in order to get a reasonable signal as to where something is, and that'll only give you a range of a circle around your pinging device. There's also passive listening, which is the other way that sonar works, where you drop a hydrophone in the water. You could set it to a pre-designated depth. When you dropped it out of the airplane, it would radio transmit the sounds that it was listening to back to the aircraft, and repeating sound signals like the twirling blade rate of a submarine moving through the water. You could tell if it was a 3-bladed propeller or a 4-bladed propeller. You could tell if it was 2 5-bladed propellers. You could tell what the speed of operation of the diesel, if it was a diesel submarine, or the cooling pumps for the nuclear submarines. There were signatures that the machines created that could be listened to with this hydrophone setup, and it would print out on a graphic page, and my job was to analyze what the target was. And then there was a second stage of using sonar, which is to drop a series of buoys that do the pinging and drop them in a pattern and be able to tell with the intersecting circles of the pings where the target is located and which way it's moving. So you're doing a combination of listening to figure out how fast the thing is going, what the target is, whether you've acquired a target, and then once you isolate the target with the active sonobuoys, you start to track it, and as it moves through the water, underwater, completely invisible. So.